Okay, today I'm going to cover chapter 1.2, graphical representation of quadratic functions. In elementary mathematics, you have learned this quadratic formula. There's a very special part of the quadratic formula, which is this part here, b squared minus 4ac. This part is something special. It is known as the discriminant. It's a discriminant because it will allow us, to discriminate between an equation having two real roots, two real and repeated roots, or no real roots at all. How this works out is because you can only square root a positive number. Okay, a positive number will give you a positive root, a negative root. You square root 0, you get 0. And then if you square root something that is a negative number, let's say negative 7, okay, this will give you an error. Okay, so this will give you no real roots. But not to worry, we will work this out shortly. Okay, so now the very first thing you to commit to your memory is the discriminant for a quadratic function is b squared minus 4ac. So this one you have to memorize this, no way around it. Okay, activity 1C can be found in your textbook itself. So if you want to fill it in your textbook, it's okay. If you want to do it on a piece of paper, but I suggest that you actually do it in your textbook itself. So now, what you will need, right, for this activity is to actually use a graphing software. Okay, so go and find a graphing software like Desmos or something to that effect on the internet. Okay, and then you need to go and type in these different equations, okay, like y minus 2x squared, y minus x squared minus 2x plus 1. So what happens here is this. For example, okay, for the very first one, if you were to type out the equation, you draw it, the system will spit out, okay, the diagram that looks like this, the graph looks like this. So you notice that, right, if I calculate the discriminant for x squared minus 2x plus 1, my discriminant is equal to 0. Please make it a point to calculate all the discriminants here. I'll actually give you the answers in the next slide. Okay, but what you need to know here is this. If the graph only touches the x-axis at one point, this is known as real and repeated roots. So if the graph touches the x-axis at 2 points like this, okay, or like this is two real and distinct roots, this one. Then there's another case whereby the graph lies completely above the x-axis, or the graph lies completely below the x-axis. This means no real roots. So try your best, okay, to complete activity 1C. So I suggest you pause, okay, the video here. Look at your textbook, it's on page 10, I believe, and try to finish this page before you unpause the video. Okay, the video will unpause in 3, 2, 1. Let's go. Okay, these are my answers here. I hope you have been able to calculate what I call the discriminant over here. So the sign of the discriminant, so like for example, this second one, you have found that the graph, okay, it is a frowny graph, but it will actually intersect, right, the x-axis at two distinct points. Hence, this is real and distinct. Similarly, for the third one, if you had drawn the graph using a graphing software, you have found that, hey, okay, my discriminant is 0, but the graphing software itself shows me that it only touches the x-axis at one point. So this is known as real and repeated roots. For the fourth line itself, if you have done it, you will find that this is a smiley graph and that it does not intersect the x-axis at any point. So this means that there are no real roots. For the fifth case, what you have found is that, hey, this is x, okay, and then it's a smiley graph. Okay, this is wrong. Okay, there's a smiley graph like this. There'll be two real and distinct roots. For the last case, you have found that the graph, okay, will be a frowny graph and that it doesn't intersect the x-axis at all. There are no real roots at all. Okay, notice, right, how these are all actually related with the discriminant over here. When it's equals to 0, it's real and repeated. It only touch at one point. When it's positive 8, okay, or a positive number, the discriminant gives you two real and distinct roots. When it's a negative discriminant, what you get is no real roots. So To make sense of all of this, there is this slide over here, which is also taken from your textbook itself. When the discriminant is greater than 0, it implies two real and distinct roots. The curve will intersect the x-axis at 2 points. When my discriminant equals to 0, okay, my graph will only intersect the x-axis at a single point. When my discriminant is lesser than 0, the graph will not intersect the x-axis at all. I think you have found that out from the previous activity 1C. So you will have to memorize this. So if we say two real and distinct roots, you must be able to say that d is greater than 0. On the other hand, if you have calculated that d is lesser than 0, you must be able to say that there are no real roots. So you must be able to go both ways with this knowledge. Now, so it means this, okay, when the discriminant is less than 0, okay, if you have a smiley graph means that the coefficient of x squared is positive. It will lie completely above the x-axis. Similarly, when my discriminant is lesser than 0, okay, and my a, or the coefficient of x squared, is less than 0, it means that it's a frowny graph. There are no real roots. It implies that it will lie completely below the x-axis. So the two cases for this will be here. The first case like this, completely above the x-axis. The second case will be completely below the x-axis. For both of these cases, it will imply that my discriminant d is less than 0. No real roots, no intersection with the x-axis. Okay, example 7. Okay, example 7 will be this. Use a discriminant to determine the number of x-intercepts for the graph for each of the given quadratic functions. So very quickly now, for part A, my discriminant d is equals to b squared minus 4ac. What I get is my discriminant is equals to 0. Straight away, you must be able to say that my discriminant equals to 0. You go back to this one. It's two real and equal, or two real and repeated roots. So it means that in this case, they will have one x-intercept. So that means here the graph, okay, y equals to x squared plus 6x plus 9 has 1 x-intercept. If you were to sketch this graph, x squared is positive, so it's a smiley graph. And then if I sketch this, this will be a wrong sketch because this has two real and distinct roots. It will only touch at one point, so the sketch of the graph will be like this. It will only touch at one single point. For part B, okay, what we have is this. Let me try to expand. So when I expand this, what I get is a squared minus 2ab plus b squared plus 1. So if I simplify, I get x squared minus 4x plus 5. My discriminant d is b squared minus 4ac. My discriminant is equals to negative 4, and this is lesser than 0. Straight away, okay, lesser than 0, what does it imply? It means no real roots. So if there are no real roots here, so what it means that you have to write that down. I say that no real roots since, okay, my discriminant is lesser than 0, okay, there are no real roots, which means that there are no x-intercepts. If I were to ask you to sketch this, if you notice, my x squared is positive, so it's a smiley graph. So my graph will actually look something like this. Y equals to 2 minus x squared plus 1. Notice that there is it will not intersect the x-axis. There are no x-intercepts. Okay, try now, pause the video and try 7. When you're done, you can unpause the video and I give you an explanation of try 7. And in 3, 2, 1, let's go. Okay, for part A, if you have calculated your discriminant, b squared minus 4ac, you will find that your discriminant is equal to 28, which is greater than 0. So now you have two real and distinct roots. I've not answered the question, so there will be two x-intercepts. For part B itself, once you have expanded, okay, you will find that your discriminant D is negative 8 and this is lesser than 0. This implies that there are no real roots and there are no x-intercepts. So, if I were to draw a sketch for you of this, what I call a graph itself, if you notice my x squared is positive, but if there are no x-intercepts, it implies that my graph will lie completely above the x-axis as shown here. This is a sketch, and then I will write there y is equals to 1 minus x squared plus 2. Example 8. Find the non-zero values of p for which the graph of y equals to px squared minus 2x plus p touches the x-axis. Touches, okay? So in this case, if it touches only, what it implies is that it only wants a single, what I call, we only want a single point. So in this case, if it touches, what they are actually asking for is that there's only one x-intercept or real and repeated roots, which means that my discriminant should be equals to 0. So in this case, what I'll do is this. My discriminant D is equals to b squared minus 4ac. Okay, then now my D is equals to 4 minus 4p squared. So what I'm looking for here is that I know that my D equals to 0, okay? For it to touch the x-axis, 4 minus 4p squared is equals to 0. Then solving, I'll get p squared is equals to 1. Square rooting both sides, p equals to 1 or negative 1. Notice that they say that non-zero values, negative values are fine. So p equals to negative 1 is also a valid answer. Okay, let me just give you a bit more connection here. If I were to draw this graph, okay, or sketch this graph, if my p value is equals to 1, it means that my x squared coefficient is positive. What this implies is that it will be a smiley graph like this, and it will touch the x-axis at exactly 1 point. Similarly, okay, if my p value was equals to negative 1, if my p value is negative 1, this coefficient of x squared will be negative. It will imply a frowny graph. So for a frowny graph, in this case, and my discriminant being 0 and touches the x-axis, the graph will actually look like this. Okay, do spend some time, pause the video and try it. And we'll carry on in 3, 2, 1, let's go. Okay, for try 8, find the values of p for which the graph, okay, meets the x-axis at 1 point only. 1 point only implies only one x-intercept. So first, I found the discriminant, and the simplified version is p squared minus, or the simplified expression rather, is p squared minus 144. For only 1 point, it means one x-intercept is real and repeated roots. My D is equals to 0. So I will equate p squared minus 144 is equals to 0. If I solve this, okay, I'll get p equals to 12 or p equals to negative 12. Example 9. Explain why the graph of y equals to x squared plus 1 minus px minus p intersects the x-axis. So they didn't tell you if it intersects one time, they never tell you if it intersects 2 times for real and distinct roots. They just tell you, explain why does it intersect. So now we cannot, okay, so the wrong thing to do here would be to make the first statement, oh, my d is greater than 0, okay, or my d is greater than or equals to 0. We don't know that yet, okay, so I'm not very sure yet. I have to explain why. So don't assume, okay, let's just do some manipulation of example 9. So first and foremost, let me write down y equals to x squared plus 1 minus p x minus p. Okay, my a value is 1, my b value is equals to 1 minus p, and my c value is equals to negative p. Hence, my discriminant is b squared minus 4ac. So if I simplify, I get 1 minus p squared plus 4p. Okay, how will I, okay, now if I simplify further, d equals to a squared minus 2ab plus p squared, this and these are equivalent, plus 4p. My d value is p squared plus 2p plus 1. If you notice, this can actually be factorized into p plus 1 times p plus 1. So this simplifies to give me p plus 1 squared. So now, what I can actually say is this, okay, p plus 1 square, when you square a number, we've done this like multiple times already, p plus 1 square will be always greater than or equals to 0. So now I can make the statement, since, okay, my discriminant is always greater than equals to 0, minimally you will have real and repeated roots when d equals to 0, or when d equals to 0 you will have real and distinct roots. So in this case, I can say, hence, okay, the graph intersects the x-axis. Okay, same thing, pause the video and we will try 9 in a short moment. Okay, and we will carry on in 3, 2, 1, let's go. Now, first and foremost, what we have to do is to find the discriminant. So what I'll do here is this, let me just rearrange it nicely. My a value is 1. My b value is negative 2, and my c value is 2 minus p. Hence, okay, my discriminant is b squared minus 4ac. So if I've done everything correctly, I will actually simplify my discriminant to 4p minus 4. Okay, you have to explain why. So you cannot just start off the bat and say the discriminant is greater than 0, discriminant equal to 0. I don't know yet. Okay, so what I need to do is to prove. So what they have given is that p is greater than 1. So I start the logic here. If p is greater than 1, for p, I multiply 4 to both sides of my inequality. 4p is greater than 4, and then 4, and then if I, okay, then I will move it over. Okay, sorry, I minus 4 on both sides of my equation. I get 4p minus 4 is greater than 0. So basically I started with p is greater than 1, 4p is greater than 4, 4p minus 4 is greater than 0. Hey, lo and behold, 4p minus 4 is the same expression here. So I can therefore conclude that my d, discriminant, is greater than 0. So if my discriminant is greater than 0, what this implies is the graph will intersect the x-axis at 2 distinct points. Example 10, the last example for today, show that the graph of y equals to x squared minus 2kx plus k squared plus 1 is entirely above the x-axis. So y equals to x squared minus 2kx plus k squared plus 1. So again, okay, my a value is equals to 1, my b value is negative 2k, my c value is k square plus 1. So my discriminant d is equals to b square minus 4ac. Then if I simplify, I find that my discriminant d is equals to 4k square minus 4k square minus 4. My discriminant in this case is equals to negative 4, and negative 4, as we know, is lesser than 0. So I can say that since d is lesser than 0, okay, and the coefficient of x square is positive in this case, so this graph here, this one, I know that my coefficient of x square is positive. Okay, the graph lies completely above the x-axis. Okay, let me just explain this one more time. Okay, my coefficient of x squared is positive. So this means that I have a graph that looks like this. Okay, it's a smiley graph. Then I also know that my discriminant is less than 0. Less than 0 means that it will not intersect the x-axis. So if I were to sketch the graph, it will look like this. It will be a smiley graph. Okay, coefficient of x squared is positive, and since there are no x-intercepts, it will lie completely above the x-axis itself. Okay, let me do B now. So for part B, show that this expression is negative for all real values of x. So for my D, okay, for this one, let's just go slow here. My A value is negative 2, my B value is 4k, and the C value is everything else, which is negative 2k square minus 1. So discriminant B square minus 4ac, like this. So my discriminant, simplifying, 16k square minus 16k square minus 8. So discriminant equals to negative 8. This is lesser than 0. Okay, few things here. First and foremost, coefficient of x squared is negative. So is it a smiley graph or a frowning graph? In this case, it should be a frowning graph. Next thing, my discriminant is less than 0. This means that there are no x-intercepts. So if I were to draw this out on a diagram, first is a frowning graph. This, if I were to draw it like this, it will mean that, hey, there are x-intercepts. But we have established that my discriminant, or our discriminant, is less than 0, so there are no x-intercepts. Hence, it will lie completely below the x-axis, or it will always be negative. How to put that out into words to explain? So you can say that since the discriminant is negative and coefficient of x squared is negative, this implies that negative 2x squared plus 4kx minus 2k squared minus 1 is negative for all real values of x. Okay, your turn. Try that. Just take your time, try it, and then when you're done, unpause the video and we can move forward in 3, 2, 1, let's go. Okay, for try 10, first and foremost, I found the discriminant. I found my discriminant is negative 4. Okay, so same thing, if you look at my diagram here, my coefficient of x squared is negative. So this implies that this will be a frowning graph, and my discriminant is negative, which means that there are no x-intercepts. So it means that no x-intercepts and it is a frowning graph. So my sketch is over here. But to explain this and to show this in words, You can say since discriminant is negative, no x-intercepts, coefficient of x squared is negative, it's a frowning graph, hence the graph lies completely below the x-axis. Similarly, for part B itself, you will find that your discriminant is equals to -1. Since discriminant is negative, okay, there are no x-intercepts as I show you in my diagram here, coefficient of x squared is positive. That means that it's a smiley graph like this. So it means that no x-intercepts, it lies completely above the x-axis, hence 1/4 x squared plus kx plus k squared plus 1 is always positive. You see all these values here, they are positive values. And that's it for this part of the video. So